Hello, my name is Yusuf Abumali. Today I will be performing an experiment to test whether a six-sided die is fair, meaning that each face, which is 1, 2, 3, 4, 5, and 6, has an equal outcome, which is 1 over 6. The statistical test that I will be using today is called the chi-squared goodness of fit test. I have the following hypothesis. The null hypothesis is that the die is fair, so the probability of each face is exactly 1 over 6. The alternative hypothesis is that the die is not fair, meaning at least one face has a probability different from 1 over 6. I will be using this die. It's a six-sided die. I will be rolling this die 100 times and recording the results on an Excel sheet. Each outcome, I will say the outcome out loud and then record it on my Excel sheet. After collecting the data, I'll calculate the chi-square test statistic and compare it to the critical value at a 5% significance level. If the test shows significant evidence against fairness, I'll reject the null hypothesis. Otherwise, I'll fail to reject it. I will start the process of rolling the die. This is going to be the Excel sheet I'm using. Here I have all of my 100 rolls, and on each roll, I'm going to put the result next to the number of roll. Again, I will be saying the roll result after each roll. All right, now I will start rolling the die and recording the result on my Excel sheet. Roll number 1, I have a 5. Roll number 2, I have a 4. I have a 2. 3. A 5. A 2. A 6. A 3. A 4. A 1, and that's 10 rolls. A 2. A 5. A 4. A 6. A 5. A 4. A 1. A 1. Another 1. A 2. And that's 20 rolls. A 1. A 6. A 5. A 5. A 4. A 2. A 1. A 3. A 5. A 5. And that's 30 rolls. A 4. A 5. A 3. A 1. A 4. A 6. A 3. A 6. A 3. And a 2. That's 40. It's a 6. It's a 3. It's a 6. A 5. A 4. A 2. A 2. A 1. A 3. Roll number 50, we have a 5, so now we are halfway through. A 1. A 3. A 6. A 4. A 2. A 1. A 5. A 5. I did not directly. A 3. And a 2. A 4. A 3. A 6. A 5, 6, and that's roll number 65. Another 6, 3, 2, another 2, and for roll number 70, that die fell. Let's try that one more time. A 3. For roll number 71, we have a 2. Roll number 72, we have a 2, a 3, a 6, another 6, another 6, a 4, a 2, a 6, a 1, and that was roll number 80. A 1, 4, a 6, a 2, a 6, a 2, a 6, a 2, a 4, a 2, and that was roll number 90. We have 10 more. A 2, a 4, another 2, a 4, a 4, a lot of 2s and 4s, a 5, a 1, a 5, a 2, and for our last roll, we get a 6. So now I'm gonna go over the results of this experiment. We had, for face number 1, we had 13 times. For face number 2, we had 22 times. Number 3, we had 14 times. And number 4 is 16 times. Face number 5 is also 16 times. And face number 6 is 19 times. These will all total up to 100 rolls. Just a quick reminder, our null hypothesis is that the die is fair. Each face has a probability of 1/6 to show. Our alternative hypothesis is the die is not fair, which means at least one face has a probability different from 1/6. So now after we have conducted our experiment, we rolled the die 100 times, we talked about the results. We're going to conduct the chi-squared goodness of fit test. So what we would do first, I'm going to talk about what the equation is. So the equation states as chi-squared is equal to the sum of all OI minus EI squared over E of I. So first of all, we want to determine what E of I is. E of I is the expected frequency. We rolled the die 100 times, and the probability, or our assumed probability, would be 1/6. So we would multiply 100 with 1/6, and we would get a result of 16.6667, which will be our EI that we will use for the equation. And then after that, we're going to apply the equation based on the result we got from each roll. So for O of 1, for example, we got 13 times where we rolled 1. So at that point, it will be 13 minus 16.6667 squared over 16.6667. Here for face number 1, our value of O is 0.8067. We'll do the same thing for all of our faces. So for face number 2, we got 1.7067. For face number 3, we got 0.4267. For face number 4 and face number 5, since they both rolled 16, we both get 0.0267. And for face number 6, we get 0.3267. When we sum this up, we get the value of chi-squared, which is 3.32 approximately. So now that we have found the value of our chi-squared, we are going to need the critical chi-square value. And since we said that our significance level is 0.05 and our degree of freedom is 5, our chi-squared, or the critical chi-square value, is about 11.07. Comparing these two numbers, my calculated number was 3.32, which is way less than 11.07. This means that the observed difference from what I saw and what I expected is not significantly or is not significant at a 5% level. In other words, there's no strong evidence to suggest that the die is unfair. In conclusion, I can say that since our chi-square value is 3.32 and the critical value is 11.07, I failed to reject the null hypothesis. This result suggests that the die is likely fair, or at least I don't have enough evidence from this sample to prove otherwise.